Okay, now we're going to get to the part that you're used to jumping into, which is crunching the numbers, the mechanics. And how do we do that? We're going to calculate the p-value, or the probability that the data is consistent with the hypothesis. So if we have a very high p-value, that's a high probability. If we have a very low p-value, the data is highly unlikely if the hypothesis is true, the null hypothesis. Some people might use 1 out of 20. Some might say 1 out of 100. You have to decide. Most of the times we do 1 out of 20 or 0.05. And I will be revisiting this when we declare our verdict in the next video. So let's go back to the 3 examples we've been doing all along. The first one being the smoke detector. And remember, I already determined the model has a mean of 0.90 and a standard deviation of 0.015. Let's go ahead and calculate the actual proportion in the sample. So before we weren't really looking at the sample except to calculate the standard deviation. Now we're going to use the sample to determine the actual proportion we measured. Then we have to calculate the z-score for that, and I'm getting 2.667. And the probability for that is kind of low. And in fact, if I were to shade it in, you can see this is 2.667 standard deviations away. And if I were to regraph this with my mean and the other values, you can see the probability is very low. So I have a very low p-value, 0.0038. Now I'm not going to do any sentencing. I just did the mechanics. All right, let's do the mechanics on the M&M example. So that one we had the normal model 0.20 and 0.0362. Let's go ahead and calculate the proportion we saw. It was 21 out of 122, or 0.172. We still have to calculate the z-score. Or, I mean, in theory, you could punch it all in your calculator, but any statistician worth their salt calculates the z-score. So, in this case, I'm going to test that it is outside of negative 0.77, all right? Because the null hypothesis is that it is equal to 0.77, and I don't really care if I'm really high or really low. So my window is going to look something like that. And if I were to calculate the probability, you would find it was actually 0.4413. And I can actually show you the curve here with the actual mean value. Here's 0.20. And we were looking at 0.172 is what we calculated. That doesn't look like it's in really unusual territory. And so when I go either side from the mean, because I'm just saying, does this contradict the 20% claim? If they have 25% orange M&Ms, assuming that one is unusual, that's not that different than having 15%. The main point is, are there 20%? So this is called a two-tailed test because I'm testing both sides. All right, last example, we're going to look at unfit teens. So here's my model again. Let's calculate the proportion and the z-score. And I'm getting a z-score of 4.08. That is incredibly high. It's way over here. So if I'm saying more than 30%, let's see, 34% is what I got. That's way over here. It's off my graph. And the probability for that is practically 0. So my p-value is pretty much 0 for this example.